With the first plugin. So the first plugin is Swisstronic. So for those who don't know what Swisstronic is a EVM compatible layer 1 built on Cosmos SDK. That's literally everything that you need to know, because from the developer experience, to build apps on Swisstronic is the same as any EVM blockchain. So let me just walk you through everything. The first thing that we are going to do is to create a node project. So I will create ETHSafari workshop. I will also push this later to the GitHub. Safari workshop. So we need to run npm init-y to create a node project. I will do maybe like a little Q&A after every plugin, in case that if you are following me, it doesn't work, then I can help you or something, to be able to really help you and that everything works for everyone. So once we create this node project, you will see that we have the package.json. Then we need to install the web3 library by typing npm install web3. And then the most important thing is that we need to install the Swisstronic plugin as well, right? So here in the second slide, I have Swisstronic resources with different links for the faucet, the testnet, the EVM Explorer. So we can come to the Swisstronic plugin. Yeah, and then we can see here the Swisstronic plugin. Basically, what I'm going to do is to walk you through the documentation to get the first kind of sample case working, because then after it works, it's really easy to just add more complexity, and I just want you to help you to get started with that. So the first thing, to install the Swisstronic plugin, so I will just copy this and then put it in my console. npm install at Swisstronic / web3 plugin Swisstronic. And then as you can see, we already have, let me do a little zoom in. We already have in our package.json the web3 library and the Swisstronic plugin. This is really important for you to know if you are applying, let's say, for Swisstronic Bounty. So for sure, the Swisstronic plugin should be installed in your package.json. And then I'm just going to create a file, index.mjs, where we are going to use the plugin. So the first thing that we need to do is to import the web3 library and to import the plugin, these two lines. So let me just comment this, import web3 and Swisstronic plugin. And then import Swisstronic from Swisstronic. Okay, so we already imported those two modules. Then after that, we need to initialize the RPC endpoint. Who don't know what is a RPC endpoint? Don't feel shy, I can explain everything. Everyone knows what is a RPC endpoint? Okay, perfect. So an RPC endpoint, let me tell you, maybe with this presentation at ETHSafari. Yeah. So when we have a dApp, we have, like, let's say, the front end of Uniswap that is using web3.js. So web3.js will connect to an RPC endpoint, and that RPC endpoint is just a URL. So depending on what URL you put there, you will be talking to a different blockchain. I'm going to show you that right now. So if you have here a Ethereum RPC endpoint, you will be interacting with Ethereum. But if you have a Base RPC endpoint, you will be interacting with Base, and so on with all the EVM. Here are some lists of different platforms where you can get RPC endpoints: QuickNode, Infura, Alchemy, or the one that I always use is chainlist.org, because there's a lot of free RPC endpoints, and that's enough for hackathons. But if you are doing like a production thing, then don't use those free ones. And then the RPC endpoint will be the one that will interact with the nodes in the blockchain. So either with Ethereum, Avalanche, Polygon, Binance, Base, etc. Then the node will execute the transaction or will retrieve the information. So I will just go to chainlist.org. Before we start with the plugin, I'm going to show you something really quick. So let me we'll just comment this.
Excuse me.
Yeah?
Could you zoom in a little?
Is that good?
Yeah.
Perfect. Okay, so the first thing is you import the web3 library. Really important, you need to use curly braces here and the web3 with the W uppercase. Then we need to initialize the RPC endpoint. So for that, I'm going to type new web3. And then here, we are going to send the RPC endpoint. So if I go to chainlist.org and I come here to take the first URL and I put it here, we are going to interact with Ethereum. So let me show you. I'm going to store this in a web3 variable, and then we are going to use this variable to do everything. Let me just show you right now. I'm going to create a sync function, and then let's use web3.eth.get block number, and maybe web3.eth.get chain ID. So let's store this in the block number variable, and then let's store this one in chain ID. Block number, and then let's do another one. Perfect. Is this clear so far? What I have done, I will just kind of use two functions, once to get the latest block number and once to get the chain ID of the network that we will interact with. Perfect. And I initialize this with the Ethereum mainnet RPC, so then let's run this and let's see the result of what we get. Let me actually put another thing here, mainnet. So node index.mjs. And then in mainnet, the latest block number is this, 20713, and then the chain ID is 1, right? But then if I go again to chainlist.org and I change to base, and then I take this one, it's basically the same, but just base. And then if I do the same, let me just change the name. So I will just run the same code, but I just change the RPC endpoint here on top. And then you can see that we got a different block number and we got a different chain ID. And that literally works with all the 200, 300 EVM networks. Just change this little thing, this little RPC endpoint, and then you will interact with that network. Except for some layer 2s that they have more specific RPC kind of calls. So that's why CK-Sync is one of them. If you do this with CK-Sync, that will work, but CK-Sync has more complexity that is not in the main library. That's why we need to use the plugin to be able to do the more tricky things with CK-Sync. But this will work with any EVM network by default. Any questions with this part so far? Perfect. So just change the RPC and then you talk to a different network. Okay, so now let's start with the first plugin.
So does this work with optimism also?
Yeah. Yeah, let me show you as well. Optimism is not here. Optimism RPC endpoint. Then we can see the RPC endpoint here, I guess. And then if I run the same code, we get the chain ID is 10, and then this is the latest block number in Optimism. So that's the web3.js library by default, right? But the bounty is not only about using web3.js, it's about the specific plugins. So that's something important to note. So now let's start with the first plugin. No questions with this, right? Before we jump into the plugins? Okay, perfect. So as I was doing first, I just import the Web3 library. We always need to import the Web3 library, and then we always need to import the plugin. In this case, this will be the Swisstronic. Let me just change the name here. Swisstronic. Then I will just create a file for every plugin. Okay. And then let's go to Swisstronic docs, to the plugin docs. After we do that, we need to initialize the RPC endpoint, but then with the Swisstronic URL. So in the docs, the RPC endpoint is already here. So I will just put it here. Then after that, there is something called register plugin that you will always need to do with all the plugins as well. And it's just basically type in web3.register plugin, and then you create a new instance of the plugin that you imported here. So new Swisstronic plugin. So basically these 4 steps will need to be done with all of the plugins. First, you install the Web3 library, you import the Web3 library, you import the plugin, you initialize the RPC endpoint depending on the network that you are interacting with, and then you register the plugin. And then after you register the plugin, basically you can start interacting with the plugin by typing web3.swiss Swisstronic, in this case this plugin, and then here we can get the different methods. But what I'm going to do right now is to interact with a contract. So I can show you that interacting with a contract in Ethereum will be the same that interacting in a contract with Swisstronic. So that's what I'm going to do right now. But before that, okay, let me tell you something about Swisstronic so you understand the plugin. Swisstronic is doing some encryption. Every time that you send a transaction, Swisstronic is encrypting the data field, and then they store this data encrypted into their network. And then what happened without the plugin is that the developer needed to encrypt this manually and then send the transaction. But then with the plugin, you don't need to care about the encryption, and everything is happening under the hood, right? So I'm just giving that explanation, but you don't need to know anything because that's just happening with the plugin. But if you don't use the plugin, then you will need to do the encryption manually. Who knows here the structure of a transaction in Ethereum? Or who don't know the structure of a transaction in Ethereum? Everyone knows the structure of the transaction? Okay, so you will learn something new today. I have this video here. This is just for you to understand, for you to understand this a little bit. Oh, I think here. Okay, so this is the structure of a transaction in Ethereum. We have the from field, which is the address, the wallet that is sending the transaction, the to with the contract that we are interacting or the wallet that we are sending funds, then value when we are sending funds, then the data field, this is the one that needs to be encrypted in Swisstronic. So that's happening under the hood of the web3.js. The web3.js plugin is using the Swisstronic library, encrypting this data, and then sending the transaction. The nonce is the counter of the transactions that you have in your wallet, then the gas limit, and then the signature. So this is the basic transaction structure in Ethereum, with the difference in Swisstronic that this is encrypted. Okay, so that's everything here with the Swisstronic. Let me just interact with the smart contract. So another question. Who has never interacted with a smart contract before? Okay, perfect. So for interaction, smart contract interaction, we always need something that is called the ABI. The ABI is like a interface that web3.js will need to be able to interact with the contracts. And this is the ABI for the ERC20 tokens, and it's the same ABI for all the tokens. So you don't need different ABIs for interacting with ERC20 contracts. I just Google ERC20 ABI, and then you will find it here, ERC20 ABI in JSON format. And then I'm just going to copy paste all this ABI here, ABI ERC20, ERC20.mjs. So const ABI, I just copied that whole thing, then export ABI. Perfect. So what I did right now, I just copy paste all the ERC20 ABI into this file because we will need it here to interact with a contract. So every contract will always have a specific ABI. So let me just show you something else where you can get the ABI if you don't have it. So let's say that you want to interact with Uniswap token. So you can come to ETHScan. You can come to contract. When the contract is verified, you will always see the ABI. If it's not verified, then you will not see it. And then you scroll down to the end, and then you have the ABI here. So contract ABI, and then you just copy paste this whole thing, and that will be the ABI that you will need. You don't really need to understand the ABI, that's not needed, but you just need to have it there because we needed to initialize the contract. Okay, so the first thing to interact with a contract is that we need to initialize the contract object. And to initialize the contract object, we need to type new web3.eth contract. And then as you can see, I just put the parentheses at this accept the contract ABI, and let me just put it here, ABI, that I just imported from the ABI ERC.mjs, and a contract address. So for the contract address, I'm going to Swisstronic EVM Explorer to get the random, any ERC20 token that they have there. So Swisstronic EVM Explorer. and they have here in the top left something called ERC20 tokens. Okay, and then here we have a lot of ERC20 tokens. I will take let's say the first one, the address, and then I will paste it here. Contract address. And then I will just put it here. Okay, so we will always need two things to interact with contracts, the ABI and the contract address. And then we just store this in a variable here. Let's call it my contract. And now to interact with the contract, we only need to type the name of the contract instance, in this case my contract.methods dot the function that we want to call. Because I already know the ERC20 tokens, they always have functions called name, decimals, total supply. Like these are the ones that I know by default, but I will also just show you that really quick. USDT. Yeah, so these are all the functions of the USDT contract, for example, name, total supply, balances, decimals, etc. So to interact with this contract specifically, we can type .name and then .call, because we are making a call to the contract to retrieve the information. And then if I want to interact with another function, the same, my contract.methods.totalsupply.call, and then the same here, my contract.methods.decimals.call. So that's how we interact with contracts. Let me show you how we do that. .name cons total supply. Okay, and then let's just print this in the console. Okay, so this is how we make calls. Now let's run this and let's see if this works. Okay, so this is the contract name, sample PRC20. This is the total supply, and these are the decimals. And this is how we can interact with a contract. It's the same as Ethereum, but then what's happening, remember, under the hood, this is sending a call to the nodes in Swisstronic, creating some encryption and all these things, and then just retrieving these values that you see here. But at the end, in the application layer, you don't need to care about something different. It's just using the plugin. But if I comment this, for example, so we are not initializing the plugin, so we are not going to use the plugin, and then I try to run this again, we are getting an error that says wrong public key size, because they are trying to encrypt and decrypt these things. So that's why the plugin is doing all this logic under the hood of encrypting the transaction. Do you have any questions with this plugin so far? Is it clear?
So the 3JS it's only for JavaScript. There are no limitations for native apps.
Yeah, only JavaScript.
What was the question?
It's only for JavaScript. Yeah. Someone else? Swisstronic plugin? Okay, perfect. So if you want to build a dApp with the Swisstronic plugin, that's what you need to do. Install the plugin, import the plugin, initialize the Web3 object here, import the plugin, and then do whatever you want here. You have more examples here in the documentation, sending transaction and performing calls. If you want to send a transaction, will be something like this. You will need to type web3.it.send transaction, and then you send the transaction object here, and then the web3.js library will do the logic under the hood as well. Okay, so I will just put this here. Okay, so can I move into the next plugin? Yeah? Perfect. So now let's go to the slides again. Here you have some resources, the plugin, the testnet, the faucet. Also, if you need any help, I will be downstairs the whole day and night as well. I don't have any time to go home, so it's okay. There's no one waiting for me at home, so that's fine. Okay, CK Sync. Actually, I will leave CK Sync at the end because it can be a little bit long. So let me just change the slides.
Maybe, what are you most interested in seeing? You know, what do you want to see next on the list of plugins that you have? Because Santiago is here, it has everything.
So I can leave that one to the end. So you keep engaged until the end.
Yeah.
Oh yeah. Any preferences? I don't have any. I don't care about the. Okay. Okay. Paymasters.
Yeah. Paymaster?
Okay, let's do Paymasters then. So let me just do something here. I will create a CK Sync file where we are going to interact with the CK Sync plugin. So the first thing, we need to install the CK Sync plugin. So if we go to the slides, here I have somewhere here. Just give me, I think I lost it. Oh yeah, I think I deleted the slides. Just give me a second, I will take it from here. I deleted the slide with the link to the CK Sync things. Yeah, this one. CK Sync docs. Which one is this one? Lagos, SDK, JavaScript. Okay. Okay, perfect. So here is the link for the CK Sync plugin. So you can just, oh, it's not there. So let me just put it here as well. Just make sure that there is CK Sync docs. Okay, perfect. So here in the CK Sync resources, the first thing that we need to do is to go to the CK Sync plugin. So this is an npm package. Then we need to install the plugin. So I will just come here, go to my project, and run npm install web3 plugin CK Sync. Then in the package.json, you will see that we will have the plugin installed here. Perfect. Now we have it here. So the first thing is to import web3 and CK Sync plugin. Okay, so this is the same thing as Swisstronic. Then the second thing is to initialize the RPC endpoint. Const web3 equal to new web3. And then here we can, another thing, if you don't put any RPC endpoint, it will be connected or interacting with Ethereum mainnet by default. So we can just leave it like that. And then we need to register the plugin. So we can go here to the docs. And then here in the getting started, this is important. You need to go to the JavaScript and then web3.js. Then we can come here, and then we need to register the plugin by typing web3.register plugin, new CK Sync plugin. But then here, this accepts as a parameter another RPC endpoint of CK Sync. So here we can have this one in the docs already. Just stick it like this. Okay, and then we can start using the plugin. This plugin is huge. It has like a lot of different things. I'm going to show you first just the normal usage of the plugin, and then we are going to dip a little bit more into the paymasters. So I'm just going to show you maybe the RPC methods. If you want to interact with the RPC methods, so you just need to type web3.cksync. You can see that here we have the cksync object showing up. .rpc. And then here we can have a lot of different things that you can use. Maybe let's try to get Get. Let's see something with gas.
So all those methods that you see here, if we didn't have the plugin built, we wouldn't be able to access those in web3.js. So now using web3.js and what Santiago is showing you, everything this, you can interact with the ZK sync chain. And so you can do everything possible on the ZK sync chain using those different methods. So we already implemented everything. So Santiago is going to show you how you can interact. And then they have something payment master, is going to explain you, which is a more complex, I would say, topic that can allow to do like creating some contract, adding some, a kind of abstraction, paying in behalf. But that's kind of the main idea, like you have all those different methods, what you look at, saying, hey, I want to get balance, I want to transfer, like that listing here that you can see on the docs that can help you building the project that you built for the weekend, and you're going to be able to interact with those directly with abstraction of the complexity of encoding specifically for ZK sync and etc. And so Santiago here is going to show you a little bit more how it's been building also something to make your life easier. So you can even interacting with the paymaster without having the hassle of creating your own token, your own like smart contract and everything.
Yeah. Perfect. So what I'm going to use here is just get testnet paymaster address, and then let's see what is the result of this. Let's put it here. Okay, so in this case, it just returned the address of this paymaster contract. But then we can have a lot of different more methods that you can call, maybe estimate the fee, if you want to estimate the fee of a specific transaction. The main thing of the bounty is to build a dApp using the plugin. So it's up to your creativity and imagination how you can use all the different things that we have in the plugin. In this case, I'm just showing you the RPC calls that we have to estimate the transaction, to get all accounts balances. You can do a lot of different things, get block details, for example. Let's use the get block details. I think we need to send a block here. Yeah, let's see if that exists, that number. Yeah, and then we just got the details of this block in case that you want to build something like a ETHScan, like a block explorer. This method can help you, but then it's just more about exploring all the different methods, but this is how you use the plugin. Just registering the plugin, then to use the plugin web3.ckSync, and then whatever that you want to do. Does anyone has any question with this usage of the ckSync plugin so far? Yeah.
So far you've been showing that already. Is it possible to do like mutation functions?
To what, sorry?
To do mutations.
Oh, okay, to send transactions, yeah. The only difference that you will need to do is, and then you need to initialize a wallet. And then we have here, I think it will be here in wallet. Yeah, so we need to import the ckSync wallet. ckSync wallet, and then we will need to come here and type, okay, new, ckSync wallet. So new web3.ckSync.wallet, it will be this one. And then you just send a private key here. And then if you send the transaction, what will happen is that web3.js under the hood will use this wallet that you just initialized to send the transaction from that account. But that will be the only difference. Yeah, I'm just showing like kind of querying because it's faster, but that's the only difference, that you will need to initialize the wallet. And then the plugin will use that wallet that you initialize to send the transactions. The same with the Swisstronic as well. Just need to initialize the wallet. Okay, that's the other thing of the wallet. I think then we can jump in the main things, that is the paymasters. The paymaster is a more complex thing, but then I built something today that will help you to just focusing on building something on top of the paymasters instead of diving a lot in the paymasters. So yeah, that's the main general ckSync use case. In case that you want to build something, that's how you build it with the ckSync plugin. But now let's talk about the paymaster part. So for the paymasters, is basically you can do whatever you want in the blockchain, interacting with a contract. or sending the transactions, or sending ERC20 contracts, tokens, but then you pay the gas fees in ERC20s. So for this specific use workshop, what I did is that I already have a paymaster contract, and I already have a ERC20 token that we are going to use to pay the fees. Because if I don't do this, what you will need to do is, let me show you really quick. You will need to come here. Where do they have the paymasters thing? Oh, they have it here. I mean, in case that you wanted to do it from scratch as well, that's also up to you. You will need to come here to the paymasters, and then you will need to deploy a smart contract. You will also need to deploy a ERC20 token, and then this paymaster contract will need to have two things, two tokens: ETH, like Sepolia ETH in this case, and then your ERC20 contract, ERC20 token. And then every time that you send a transaction, a call will be made to this contract, and then this contract will pay the fees using that token, right? Or the ETH. But then for the final user, he doesn't need to have ETH. He just needs to have the ERC20 contract. So let me just show you what I have in this plugin so far. I already published this code. This code is a little bit overwhelming, so I'm going to explain to you everything. But this is a script that I made this morning to help you to send ERC20 tokens between two accounts. So what we need to do is to, I also published this on GitHub. Let me show you. It's here. My GitHub is Santiago DevRel. Then in the repositories, is here. CK-Sync Paymasters ERC20. Okay, so then let me tell you what we are going to do. In this CK-Sync Paymaster resources, I have all the resources that you will need, because you will need to mint the ERC20 token that you will use to pay for the fees. In this case, this token is called Crown. Here is the link of the token. If you don't know how to mint tokens, I'm going to show you right now. You will come to the token here. You will click in contract. You will click in write, and then you can click in mint, right? And then you can put here your address. Good. You need to have CK-Sync Sepolia testnet, otherwise it will not work. So 2, and then the amount. Remember that this is all the ERC20 contracts, they have 18 decimals, so that will be 10 to the power of 18, so something like this, to have one token. If you don't know that, you can come here to way to ETH, like a converter, Ethereum unit converter, and then you can see that 1 Ether is equal to this value in way, and all the ERC20 contracts, normally they have 18 decimals, so that's the value that you need to send to mint one token. So then I will just send this value here to mint 1 token. Then you need to connect the wallet. I already connected here. Right. Hopefully it works. Yeah. Sometimes it shows an error here, but you just refresh and try until it works. And then I confirm. And basically what I'm doing is just minting this Crown token into my wallet, because we will need this token to pay for the fees. So we are going to pay the fees with the Crown token. So yeah, in this case, I just minted the token as well. Then if I go to the Paymaster Sepolia contract, so all of you, in case that you follow what I have here, you will use this Paymaster contract. And this Paymaster contract will need to have ETH, and will also need to have Crown. This morning when I was trying to play around with this, they kind of were running out of Crown, so I just minted more Crown to this contract, so you have more Crown. But in case that someone used all the Crowns of these Paymasters, you can just mint Crowns, put in the Paymaster contract, in case that there is no Crowns here, because the Paymaster will always need to have these two tokens. Okay, so far we have the ERC20 contract Crown and the Paymaster as well. Okay, let me just remove this. And then we have USDC. So what I'm going to perform right now is I'm going to transfer USDC to a random address, but I'm going to pay with Crown, the gas fees, right? So I just wrote the whole script that now I will walk you through. And then you will see that my ETH balance will be the same, but then my Crown balance will go down because I pay the fees with the Crown balance, right? Let me just, oh yeah, and then this is the USDC contract that I have here. So yeah, this is the script that basically you will need to have as well. So just zoom in a little bit more. Yeah. So first we need to initialize the Web3 module, and okay, here we initialize the plugin with the Sepolia testnet. Then we need to register the plugin with the CK-Sync plugin here, and then send in the Sepolia CK-Sync RPC endpoint. Here we are going to initialize a wallet with a private key. So we can get a private key. Let me just change to this one. We need to click here, yeah, these three little buttons, account details, show private key. Then you put your password in MetaMask. And then you need to hold the cursor here, and then here is your private key. Remember to never use real funds wallets here, just testnet accounts. And this is the private key that we got, and we need to put 0x because all the values in the blockchains are always hexadecimal values, hexadecimal strings, so that's why we need to start with 0x. Any questions so far with what I have done until here? Perfect. What I did here was to initialize a wallet with this private key. So what you will see is that we are going to interact from this wallet that I call it CK-Sync Paymaster. Okay, then to initialize the wallet, you were asking me how we can do that. In this case, with the CK-Sync plugin, new web3.ckSync.wallet, and then I send the private key here. This maybe I will hard code this to make it shorter. Yeah, it's 5N. We'll just try to have less lines of code to make it a little bit easier to digest. And then one. Okay, so I just deleted 2 lines of code. Then what we are doing here is getting the USDC address, just to show you where the address is, but you don't need to know that. I'm getting that from here. Yeah, here. So L2 provider .L2 token address, and then I'm just sending the USDC address of the layer 1. Who knows what is the difference of a layer 1 and layer 2? Or who don't know that? So I just explain really quick.
I don't.
Okay, so layer 1 is basically Ethereum. Everything is in Ethereum, right? And then CK-Sync is let's say another blockchain built on top of Ethereum, and they process the transaction in a different way, and let's say they batch their transactions and they register those transactions in Ethereum. But they have like their own systems. There are like different layers, the application layer, the settlement layer, but we don't need to know that. So CK-Sync is just doing their own things in their blockchain and registering that in Ethereum. That's why that's called layer 1 and then layer 2 here. And then there are a lot of layer 2s as well, like Base, Optimism, and Arbitrum, and they do their things in their way, but they register that in Ethereum as well. That's why they are called layer 1s and layer 2s. So there is a USDC in a layer 1, and then there is also a USDC in a CK-Sync. So that's why here, if I send this L2 provider.L2 token address, sending the address of the USDC in the layer 1, this will also return the same token in the layer 2 in CK-Sync. So this is just for you to know, but we don't need to know this. It's not super like useful for this specific use case. Okay.
What do you think, how should you say it towards that?
Okay. Okay, there is something called the, I don't know if it's called the blockchain trilemma. Trilemma issue. Let's see how is that called. Oh yeah, the blockchain trilemma. So there are 3 things that we always try to have in the blockchain, and is the scalability, security, and decentralization. But Ethereum itself cannot have the 3 of them. Normally, they can only have 2. When it's secure and it's scalable, then it's not decentralized, because then the nodes will be centralized, or vice versa when it's the other ones. So then the layer 2s are basically a solution for this trilemma, because then let's say that CK-Sync will provide the security, and then Ethereum can provide the scalability and decentralization. Or then the other layer 2s are also offering a solution for this trilemma as well. So that's the thing. The blockchain trilemma is the main kind of, how can I call that? The main root of all these layer 2s is to solve this issue of the blockchain trilemma challenge.
So it's for For developers, they use L2 so they can have faster transaction for lower cost.
Yeah, while still using the security of Ethereum. Okay, so that's. I will run first the code, and then I will explain what the code is doing. So let's see if this works. And I'm going to show you all the console logs that I have here, because it's just a lot. So I'm transferring USDC from my account to another account. So I'm going to show you all the different, let's see if I can put this.
So are you transferring USDC from mainnet to?
No, from zkSync one account to another account in zkSync. Yeah, I'm going to walk you through the codes. It's a lot, but first I want to show you that everything works here. So I divided this into different balances. First, I'm going to show you the ETH balances, then the USDC balances, and then the approval token. The approval token is the crown token, the one that we are using to pay for the gas fees. So if we check the sender, which is my account, we can see, let me just copy this here. We can see that when I put Control F to search for the values, these two values are the same. That means that this was the balance of Ethereum in my account before sending the transaction, and this was the balance after sending the transaction. So it's the same. So we just sent a transaction with, and then the ETH balance still the same. Then the paymaster balance of Ethereum changed a little bit. Remember that the paymaster will have ETH, and also will have the crown token. So this is the paymaster before, as you can see, is this value, and then if I remove some characters, yeah, then it's different. You can see that here start with 49 and here start with 50. So the ETH balance of the paymaster contract decreased a little bit, because then the paymaster is the one that pays for the fees in the background as a developer. But then for the user, they only use crown tokens, right? Then if we check the USDC balances, this was the balance of the sender before. So we have 299955. But we just sent 5 tokens. I'm going to show you where was that. So the balance decreased by 5 because we just sent 5 USDC. Then the receiver balance, that is a random address before sending the USDC, was 0, and then now is 5 because we just sent this 5, right? And then the approval token, which is the crown token. Let's see this. This was the balance of the sender before sending the transaction. And if I remove this, now the balance after sending the transaction, after sending USDC. Remember that we are not sending crown tokens, but we are paying the gas fees with the crown tokens. It decreases by 1. So this transaction cost us 1 crown token to send like USDC. And we can send, of course, more USDC, and we'll change, the value will be 1 crown token that we are paying for this transaction specifically.
So Santiago, what would it mean for a user, when they do that? What's the, having that workflow, like because there's the paymaster, what it would look like for a user from a user's perspective when they send a transaction? Say for instance, like what you're showing here is like I'm sending some token to someone using zkSync. And so in a normal case, I would need to have also, like say USDC on zkSync and also some zkSync piece. And I will need to have this in my wallet to send that transaction. But what you're saying is like here, and then you stop me if I'm wrong, but I would be able to send directly, transfer some USDC within the zkSync ecosystem
without having it.
And I don't need to have like ETH also on my wallet. The master will take care of it.
Yeah, exactly. You just need to have crown token. But then another use case that for me is the most important, because here we are still talking about 2 tokens, USDC that we are sending, and then the crown token that we are paying the fees. And we still have like 2 tokens. But then for me, personally, maybe you can also find different use cases. I will say that if we can wrap this into only 1 token, that I send, let's say I send crown token, and then I also pay the fees with crown token, that will be another level, because then we are kind of removing from the picture always having a fee token and then having the token that we are sending. So that will be even more interesting. I'm going to show you what you will need to change in the code to be able to send the crown token, for example. And then you can just wrap and abstract everything for the user to only 1 token, like we do in normal life. Like when we charge the M-Pesa, we only need Kenyan shillings. We are not paying the gas fees in USD and then charging Kenyan shillings, right? everything is into one single currency, and then that will be a really good use case, for example, using the paymasters, just having one for everything. I'm going to show you what you will need to change that in the code. Does that solve your question?
Yeah, thank you.
Oh yeah, so then as you can see here, it's just decreased by 1, my crown balance. And then the paymaster actually received the crown token because that crown token that was paid was sent to the paymaster. So then as you can see, the paymaster went from all these values 6 to 7. So basically this token that decreases from the sender was sent to the paymaster, and then the paymaster paid the fees. So all the magic is happening in the paymaster. If you want, you can just go to the CK-Sync docs. You can read about the smart contract of paymasters. You can deploy your own, or you can use this one with the crowns, and it will be just easier. That's why I created this, but you can also play around with more things. So now let me walk you through the code. Someone has any question with this so far? Maybe to repeat something from here. Yeah, I think the concept is pretty clear. Paying in crown tokens. That's the main outcome of this.
I have a question.
Oh, yeah?
I think it's about the contract that is being with
The code. Oh, okay, so then let me, after the code, then you ask me again. Yeah.
Okay, so the users also have crown tokens.
Yeah. Yeah, so then the user will also have crown tokens. But then that's why I think if we manage everything into one token, then that will be easier. Because yeah, normally if, let's say that I won the hackathon and I won 200 USDC in Ethereum mainnet. So I received my 200 USDC in Ethereum mainnet, but then to send that to my Binance account, I need to send ETH to my wallet so I can transfer that, right? But then that's the same thing. Having just those two tokens is too much. We always need to have the currency that we are paying the fees. But then if we can wrap everything into one token for everything, it will be great. That's like a really good idea. But yeah, you will need to have crown token. That's why I have the address of the crown token here that you can mint. So you can have unlimited crown token to pay for the fees for the sake of the hackathon. Any other questions with this? Yeah.
You said when you want to have the thousand tokens, you have to pay, right?
Yeah.
So how many tokens
There is no limit. Yeah, you can come here, crown token. There is actually no limit. This is like this paymaster contract, and the crown token is like an example that CK-Sync have in their docs, and they don't have a limit, to be honest. You can see that people are just minting. Or maybe that was me. But yeah, there is not really a limit of crown tokens. Let's see the total supply so far. Is this huge number? But yeah, there is no limit. And then if you need more or something happen, let me know and I can send you crown tokens. But because this is an open ERC20 contract there, it's just free to mint as much as you can. But if you want to do everything from scratch, you can create your own ERC20 token, and then you will pay with that ERC20 token instead of the crown. In case that you want to do that from scratch, but I will advise to just use this crown token for that. And the paymaster contract is kind of, let's say, linked to the crown, right? But then if you do everything from scratch, you need your own ERC20 contract and your own paymaster that are linked together as well to pay for the fees. That's why I kind of set up this for you guys for the hackathon to make your life easier. Okay, something else. Yeah, I need to be also really honest with this. I'm going to show you right now. I just show you how to transfer USDC, right? But there are more things that you can do. That is, let's say, sending ETH and then paying the gas fees in CK-Sync. I also have a script for that, but I didn't have time to put that beautiful and readable like this. But that's something else that you can do. Or then the other thing is actually interacting with a contract and using the crown token to pay for the fees. I also don't have the script for that, but I can play around with that today. And in case that you need that, I will also have the script later today. But yeah, for the workshop, I have this script of sending a token.
Yes, so I have a question because I think I went through that recently. Let's say I have some, I'm going to bridge some, let's say, USDC from mainnet to USDC to ETHSync. And so then I have my wallet with some USDC, ETHSync, but then I want to convert those USDC, let's say, in some other token from the ETHSync ecosystem. Usually I would need to have some ETHSync ETH to be able to do any activity on the network. But now, the the people building, let's say, a bridge within EasyGuessing, they say, hey, we're going to accept your USDC on Zcash as a gas fee, and so we'll be able to interact with their dApp, where usually it would work like this. So it would like allow me to take that, and so developers, they can build something. Am I understanding correctly?
Yeah. For example, let's say that Uniswap is using paymasters, right? So what Uniswap can do is that they can have 10 different paymaster contracts, and every paymaster will link to a different token. So let's say paymaster USDC, paymaster Uniswap token, and that will allow the users to use Uniswap, paying the gas in USDC or paying the gas in Uniswap token, or with any other tokens. But then for every token to pay the gas, they will need to have their own paymasters. That's why in this case we have Crown. We have Crown token for the hackathon, which will be a little bit easier. Yeah, any other questions before we go into the code? Okay, perfect. Okay, so here I named the variables really easy to understand. We are querying the balance of the paymaster, the balance of ETH of the paymaster before. To do that, we just type L2 provider. The L2 provider is this, wallet.provider. Get balance, and we just type here the address of the paymasters. All these things is just to show you in the console, but you also don't need to do that. The only code that you need to use a paymaster is this. But before that, I'm just going to walk you through everything that I have here, so you don't get overwhelmed with all the code that is there. So yeah, this is how we query the ETH balance of the paymaster contract. Then here, this is how we query the Crown. In this case, I call it approval token, but it's called Crown. The Crown balance of the paymaster contract, because remember that the paymaster will need to have Crown and ETH. So L2 provider dot get token balance, then the Crown token address, and the paymaster. If you wonder, I have this constants here, that is the USDC address in the layer 1, the approval token, which is the Crown token, and then the paymaster address. So those are the three things that are constants here. So this is how we query the balance of Crown tokens in the paymaster contract. Then the balance of ETH in the sender like wallet before we send the transaction. Then here the balance of USDC is the same wallet.get balance, and then we just send the USDC address of the contract address. This one is also the approval token, just call it like this. The balance of the approval token of the sender, so wallet.get balance. This is how you query balances, wallet.get balance, and then we just send the approval token address, which is this one. Then here, I just created a random wallet. That is the one that we are going to send the 5 USDC. So we just create zkSync wallet.create random, and this will return a new wallet. And then here is the balance of this random wallet that I just created of USDC before. That's the one that we see here, this 0. So we just use L2 provider dot get token balance, then the address of the USDC, and then this address that we just created. So random.get address. Any question with these queries here? Perfect. And then basically that's the same, but after. I was doing the same thing, but then after the paymasters. So I will not explain that after, it's just the same. And then let's just go into the code of the paymaster, which is just this thing. So to send a transaction using the paymasters, you just need to type wallet.transfer, and then this will have all these different parameters that we see here. First is the token that we are transferring. In this case is USDC, right? If I change this for approval token, we are going to send approval tokens. I'm going to try that as well in a few minutes. But yeah, here is the token that we are transferring. Here is the address that the receiver. So we are just querying again this random address, because we are sending 5 USDC to this random address. The amount, I'm just sending 5. And then we need to open this new object here, that is get paymaster patterns. The first thing that it will accept is the paymaster address. So if you create a new paymaster contract, then you will need to put here the address of your paymaster. But here you can just use the same code, the same paymaster address. And then this will have these parameters here, these properties. The first is the type So this is basically just by default in CK Sync docs. You just need to put approval based. Let me just go here to also show you. That's the code that I have, but that's also here in the docs. Yeah, here is the same code that you have. The only thing is to set the paymaster and to set the ERC20 tokens that I already did for you. Then the second thing is the token that is connected to the paymaster contract. In this case is our approval token. If I put USDC, this will not work because the paymaster contract is linked to the crowns, right? Then the minimal allowance is kind of the allowance that we are giving to the paymaster contract to take from our wallet. In this case, I just put 1, so the paymaster will only take 1 crown token from our balance to pay for the transaction. And then this inner input, honestly, I don't even know what that is. It's just there. They don't even have an explanation here for this inner input. Let's just put it there, new uint 8 array. And that's everything. This is a transaction object that we are putting here. We are saving that into this transaction object. And then we just type transaction.wait, and this is sending the transaction. And here we are querying the transaction hash by just typing result.transaction hash. Does anyone has a question with this transfer here? Okay, that's good. Then yeah.
That amount, the one that you initialize the payment from,
This one?
the amount.
Yeah. I didn't get that. What is the amount?
The amount must be in the form of a big.
Oh, I can't hear you.
Must it be in big?
Oh, good question. Let's try. Let's just put 5. And let's see if that works. It says that it's accept a number, so I think it will work. Yeah, it worked. So yeah, let's just put 5. Because I just saw that in the doc, so I just put big int. But you can just set a number and that will work. Yeah, any other question?
What does USDC L2 mean here? Does this like mean that USDC only kicking? Or what?
So USDC has one contract in Ethereum mainnet in Sepolia, Ethereum like Sepolia testnet, and then another address in CK Sync testnet, right? So in this case, USDC L2, let me just show you in this way, you will understand that easier. USDC L1 is this address. So if we go to Sepolia ETHScan and we put this address, this is the USDC contract in Sepolia. Sepolia is the testnet of Ethereum mainnet, right? And then if we go, let me just see, read as a proxy, name. As you can see, this is USDC token in Sepolia testnet, which is the testnet of Ethereum. And then if we go to CK Sync Explorer, and then here in this little, forgot the name of this little thing, this little arrow, you have CK Sync Era mainnet and Sepolia testnet. So then CK Sync Era mainnet is the mainnet of CK Sync, and then the testnet is the testnet of CK Sync, right? And then if we put this address of the L2, this is the USDC contract in CK Sync testnet. And then if we go to, let's say, Binance Smart Chain, there will be another USDC contract in Binance Smart Chain, and so on. There is always a different contract address for every chain. That's why it's just a lot of, a little bit messy with a lot of different contracts, a lot of different addresses, a lot of different things, that if we can wrap everything into one token to do everything like we do in real life, right? That's why we struggle a lot. When we come to Kenya and we have dollars, then we need to switch to Kenyan shilling. So if we go to somewhere else, then we need to switch to another currency. But then if it's, let's say there is only one currency for the whole world, that will be really easy, right? So this is like the same thing in blockchain. If you are using in Polygon Matic, but then in CK Sync you need CK Sync ETH, and then if you go to Ethereum mainnet, you need ETH. It's just a lot of mess to pay the gas fees, and that's why paymasters will be really good. At least having a dApp that can accept one main currency for everything, it will be a really good use case, at least for the user experience. That will be amazing. So yeah, this is basically what I have. And if we change this token for approval, and then I will just run the same script. And remember that here the USDC balances were changing because we were sending USDC. But then in this case, I just changed the token for approval token. That means that we are going to send approval token instead. The approval token is crown, remember that. So if I just change that to crowns, we can see that the sender USDC balance is the same before and after, and also the receiver USDC balance is the same before and after, because the thing that we sent was approval balance, not USDC. So that's the only parameter that you need to change in case that you want to send a different token, or if you want to send another token that you created, then you will just need to change this. I know that maybe you will have more questions when you try to implement this in the dApp, so I will just be downstairs trying to also play around with the CK Sync paymasters in case that there are like more advanced questions that we don't know either. Just play with the docs. Any other questions before I jump into the next plugin? Yeah. No. Okay. So yeah, this code that I have that I just show you is here, and then we can jump into the next one. Here are also all the different resources in case that you want Paymaster, USDC, whatever. Here in the Paymaster ERC20 example script is the link to my GitHub with that code. Remember that you need to put a private key here to interact with the contract. And another question that I know you will ask me, I don't have the answer right now, but I can give you the answer when we go down and I start playing around with this. How we can interact with this without putting a private key. Right? Then we will need to initialize the wallet using an injected provider. I don't know exactly this right now, but I will show you how that works. It's something like web3.js. It will be something similar like this, but then you need to type window.ethereum. I might be wrong with this, but it's something similar like that I will give you the answer later. Because yeah, in our React app we cannot hardcode a private key, or we cannot ask the user to put a private key. So I will give you an answer on this when we go downstairs in case that you are struggling with this. And that will be in the docs as well, but yeah, we can check that specific thing later. And yeah, let's move then into the other one. The namespace plugin. Who don't know what is ENS? ENS is Ethereum. Oh, I even forgot what is ENS. Ethereum name services. Yeah, Ethereum name services. So what happened is that you know that sending tokens or sending transactions, we always need to input a wallet. So if you want to send tokens to me, I need to give you my wallet, which is this random string 0x5c20 whatever. But then the ENS, what it's doing is basically allowing users, anyone in any network, to buy a domain, and that domain will end in .eth. So for example, I already have a ENS that is called santiagodevrel.eth. So if we check ENS, I have it in mainnet. Oh, how can I check? I don't know how we can check that. Oh, actually in ETHScan. If we go to ETHScan, which is the block explorer of Ethereum mainnet, and I type santiagodevrel.eth, that will link you to, that should link you to my wallet. Yeah. Then this is my wallet here, as you can see, and then the same. If we type vitalik.eth, then this is Vitalik address. So the ENS is just a way to abstract this complexity of the wallet addresses into a readable domain. And then if you send tokens to santiagodevrel.eth, you will go to my wallet. So that's just a nice way to, let's say, play around with identities in the blockchain. If maybe there is an identity track or something in the hackathon, you can play around with this plugin. So to interact with the plugin, I will create here a...
So I was just one idea I think I was trying to propose here. For instance, you use, like, right now your phone number, I think there's a lot of your payment identity here in Kenya because of M-Pesa. And so you could imagine adding something with ENS, and your phone number, that you define a function, to do like, one-on-one, providing like an ENS name or a phone number to an ENS, and that could be something you could play around as a from. So you would have, from a, let's say from a ENS name, you can create like a read the phone number, and then you can also do like a different contract. So people that could maybe have a payment system, so either go to M-Pesa using this API, or going to Ethereum or Zcash or any EM type of blockchain. Those are the type of things you can do. Like ENS is really like the same as DNS, but it's decentralized.
Yeah, that's true. For example, last week we got in the Web3 Lagos hackathon some guys that built like a voting system using ENS. So then I can go to that vote, and then I need to prove that I am Santiago DevRel.eth with my wallet address, like sending the transaction from there, and then I will be allowed to vote if I'm in the system. Otherwise, then I will not be able to vote in the system. So yeah, it's just about identities or trying to connect that with phone numbers or whatever. That's like a really interesting plugin. So same thing as always, import Web3 and plugin. Oh, I forgot to install the plugin. So let's go here. Then in the next slide, here is the link to the namespace plugin. Just close all these things. So we just need to come here, copy this, then run npm install namespace ENS Web3 plugin, and then you will see it in the package.json here. So import Web3 from Web3, then import ENS plugin from this, then initialize RPC endpoint, same const Web3 equal to new Web3. And then here, let's interact with mainnet, yeah, because I'm not going to send transactions, just query again. So if I don't put any RPC endpoint, we are going to interact with mainnet by default. And then let's use the plugin here. So to use the plugin, we need to type the same thing, web3.ens. And then here we have different methods. In this case, I want to get, I think this get address. Yeah, this get address. And then if I put Santiago DevRel.eth, and then I run this. Let's see if this works. Okay, so I think this is not a function. We'll see all the different functions here. Ooh, get address. That's supposed to be a function, but I don't know if these guys changed something. Web3.ens.getAddress. Yeah. Okay, I guess this is not working, so I will need to talk to the ENS guys, to the namespace plugin, because they just updated this. Let's see which function they have here. Or, oh, okay, no, I know what happened. I missed the most important step, register plugin. When we don't register the plugin, then Web3 don't know what is this ENS thing. That's why we always need to register the plugin to be able to type web3.ens or web3.cksync or web3.swisstronic. That's why the register plugin step is really important. So web3.register plugin, new ENS plugin. And then here we can use the chain. In this case, I will just import this chain.mainnet because we are interacting with mainnet. And then if I run this again, hopefully we'll get my address. Yeah, so then this is my address in mainnet. I will say that a really good thing that you can do here is to actually register a ENS domain. To register a ENS domain, you will need to use these two functions, web3.ens.commit, and then you need to send a registration request. A registration request is this interface that you see here. First is the string that you want to, let's say, buy. So here, let's say Santiago DevRel.eth. Then the owner will be the address that is connected to this label, to Santiago DevRel. This by default, you can just put here, they have like this number here, of for how long you want to buy or set this domain for. So if it's for 1 year, you can put this number. A secret, this secret can be any random string. Then the resolver, okay, the resolver is something important that you need to know. The resolver is the ENS contract in that chain. So the resolver, we have a ENS contract on mainnet, but then there is also a different resolver for Sepolia that I can, let me actually put that in the docs right now, because that will be a interesting thing. If you want to register a ENS domain in Sepolia, you will need this Sepolia resolver. And let me just get that from here, this guy, because we got into this issue in Nigeria as well. Ooh, I haven't, I don't know if it's the internet, but it's not loading anything, or maybe it's here. Just give me a second. Yeah, okay, so this is the Sepolia resolver, because I guess you will not use mainnet to do these things, so you can use this one. This is only in case when you want to register a new ENS domain. In the resolver, you need to put that string to interact with Sepolia. Then this set as primary, by default, just put true, that would be fine. And the fuses, by default, just put 1 as well. We don't need to really deep into those concepts. And fuses, 1. Perfect. And then when we create this interface, this object, we will use the web3.ens.commit. We send the registration request, and then we need to wait at least 1 minute to then call this register ENS domain. So you first commit, you wait 1 minute, and then you register. That's something important to know, those 2 different steps with the time. Then after you register, then that will already set your Santiago devrel.eth to the wallet address that you input here as an owner. Does anyone has any question with the namespace plugin? Clear? Amazing. So yeah, that's kind of the things that you can do with the namespace plugin, playing around with identities. I also have here, like always, like a code sample that can help you to get started just by copy pasting. And okay, and then one of the most, I will say, popular ones that we got in the other hackathons, because it's interesting, is the Aura AI plugin. So Aura AI, I will call it like a ChatGPT on chain, because what we are going to do with the Aura plugin is interact with a contract, send in a prompt, and then it will take some time to generate the result, and then it will return the results like a ChatGPT on chain. For this example, let me actually create a dApp, because I want to show you the last thing. Maybe npm create byte. I'm going to create a React app using byte here. Okay. Byte project. I'm going to show you now the last step, because remember that the dApps needs to be deployed on Flick. So I'm going to show you now how we are going to create a dApp, interact with Aura plugin, and deploy this on Flick. So the first thing is we need to create a GitHub repo with our React app. So I'm going to create a repo here. dApp ETHSafari. That's public, create repo. Then I'm going to come here and open our byte project. And then as you can see, we have all these things here. This is just the byte or React app by default that we have. And when we create the repo, we can see this or push an existing repository from the command line. You can also do this manually if you have GitHub app in your computer. But in this case, I have this Ubuntu, so I just copy these lines by clicking here. I come to my React app, I paste that, and it doesn't work. So then let's try this. Yeah, and then it just works. Git add, git commit, git push. Okay, and then if I refresh this, you can see that now I just push my whole app here. Okay, then by default we need to run npm install to install all the dependencies. This is just by default the things that you need to do with React. This is not anything with web3.js or the plugins. Then npm run dApp, and then we can see that by default this is the Byte app that we have. Then I'm going to go to this app.jsx, and I will delete a few things here. And delete this. Can delete this button. And this. Okay, and these two. Okay, so basically I just deleted everything, and what I'm going to do is to create one button that says send prompt to Aura, another one that says fetch result from Aura. Okay, so then we have these two things here. Maybe let me put it. Okay, now it looks better. Now let's go to the Aura plugin, because we are going to install the Aura plugin. Okay, first we need to install web3, so npm install web3. And now here we have the Aura plugin. In the Aura resources, we have the Aura plugin link to the npm package. Then we copy here this, we go to the dApp. Then if we go to the package.json, we can see that we have where we have web3. Oh yeah, we have web3 here, and then the Aura plugin here as well. Any questions so far with what I have done? I just created a Byte app, I installed web3 and the Aura plugin. It's here in the resources. Yeah, the URL of every npm package is in the resources slide here. Then the same thing as we were doing before, import web3 from web3, and then import Aura plugin from the Aura plugin. So import models. Then the second thing is initialize the provider. So in this case, we are not going to use a RPC endpoint. We are going to use an injected provider. Injected provider is MetaMask, or the wallet that the user has in their browser. So that's why we type window.ethereum. And now let's go to the Aura docs. And I'm going to explain to you these models first. So they have three models in the AI contracts. One is the Llama 3, and this is like text-to-text model. It's one of the best available that they have. Then OpenLM, highly performant trainable text-to-text model. And then the one that I'm going to use today is the Stable Diffusion. So just for you to know the different models that they have. We can import the models here, models, and also we need to import the chain. Remember this step, register plugin, the most important. I'm sure I will never forget that step again. Web3.register plugin, new Aura plugin, and then when we put the parentheses here, we see that the Aura plugin accepts a prompt address as a parameter, but that's the chain. And we have all these different chains. Maybe if you are going to build something in Base, then you can also use the Base. I guess they have a Base testnet. I don't know. You can ask them too. Optimism as well, but I'm going to use Sepolia. Okay, and then we can use the plugin. So this plugin has this kind of two different steps. One, send the prompt, and that takes some time, let's say 30 seconds, and then one to fetch the result. So I'm going to have this function, let's say send prompt, and then this one, fetch result. And then we are going to connect these buttons with every function. So this send prompt to Aura, we type on click, and then send prompt. And then this one on click, fetch results. Perfect. Okay, and now to send the prompt, we can go to the docs of Aura, because we need to call two functions. One is to estimate the fees, and then the other one is to send the prompt actually. So first thing that we need to create is a prompt. So const prompt. Okay, who can tell me a random prompt? Or I will choose a random person. Okay, you. Random prompt. We are going to get an image. So ask to create an image of something.
Apple.
Apple?
Yeah.
Okay. Create an image of an apple, and you tell me another object, any random object.
Tree.
What?
Tree.
Tree? Oh, a tree, okay. With a tree. Okay, so this is the prompt that we have. That's the first step. Then the other step is to estimate the fee. So remember to use the plugin web3 dot the name of the plugin, in this case Aura. Then dot estimate fee. And then here we need to send the model, right? So the models, remember that we imported the models from here. So I will just type models dot. And then here we have the three different models. So I will use stable diffusion. Basically, these are just enums that they have here, different models. And then this will return a number with the cost of the fees. So I will just print that in the console. Or actually, I can do, who is familiar with React? Oh, who is not familiar with React? Who is not familiar with React? Yeah, it's always better to ask who is not. Who is not familiar with React? Everyone. Okay, so the only thing that I'm going to do here is React has something called use state, and this is just to render thing in the front end. I don't like to put a lot of lines of code to not kind of overwhelm with a lot of code, but since almost everyone is aware with React, I'm just going to create this use state just to show the fees in the front end. So const fees, set fees, then this use state. Let's say 0 fees. And then the way that we can render this state that I just created is by putting here fees and then putting here the state. Then let's see if this works. Yeah, so right now by default I input 0 fees here, but you can put any value and then it will show this value here by default, right? So I just have 0 fees. Because then what I want to do is instead of printing in the console, I want to show that in the front end. So to set that, we need to use this set fees, and then I'm going to put this fees that will return here. I think this will return a string. If that returns a number, then I'm just going to parse that into a string. We cannot render objects, so if you are returning and receiving an object here, you will need to just choose one of the properties within that object. Okay, and then let's actually try this now. If I click, remember that this send prompt button is calling this function. So if I click that right now, we are going to see the fees, right? Something important that you have to know right now is we initialize the Web3 object with the window.ethereum, but we never specify which network, right? In this case, we are interacting with CK Sync Sepolia because the user, in this case my computer, is connected to CK Sync. So then I will need to switch to Sepolia to be able to interact with Sepolia. So that's why if I click here in send prompt to Aura, that will not work. And then I can show you what we are getting. Yeah, we are getting this error. Values are not valid because what's happening right now is that we are calling the smart contract in CK Sync, but that contract doesn't exist because that contract only exists in Sepolia. So here maybe you can add like a little validation to the user, like, hey, please connect to Sepolia or something like that. So if I change to Sepolia and then I click in send prompt, we have the fees. So that's something important in case that you face that error. Make sure that your MetaMask is connected to the wallet, to the network that you are interacting with. In this case, Sepolia. Does anyone has any question with this part? I like to stop little by little. Yeah? Oh, wait, sorry? Did I? Yeah, then you will need to import the RPC URL, because then there is no like a injected provider in. So then you can use web3.it.sign transaction, and you can sign the transaction. You send the transaction object here, that will return the transaction signature, and then what you can do is to submit that transaction by typing window web3.it.send sign transaction, and then you can send the signature here. And this is how you sign it and send it. Let me just do some in, and you can take a photo. Sorry? Oh, yeah, so then you will need to do this as well. Cons wallet, web3.eth.wallet.add, then private key. But then something important is to create the transaction object. And then when you type the from, you need to type wallet in the slot 0 dot address. And this is basically using the wallet that you just initialize here with the private key, and then let's say 2, whatever, and then if you are sending value, let's say 1. So take a photo of this. What I'm showing here, guys, is he wants to send transactions, but then signing the transaction with a private key and then sending this transaction. So first you need to initialize a wallet with a private key, then you create a transaction object. In this case, we are sending one way from this address to this address. We sign the transaction by typing web3.it sign transaction, and then we send the transaction object. And then this is using this from address under the hood to sign the transaction, and then to send it, then you need to send the transaction here. I think when you are sending raw transactions, you need to add more parameters here, like max priority fee and all these things. That's actually in the docs of web3.js. Wallets and accounts, sending transactions, and then you have here send a raw transaction. And then you have here from to value max fee per gas and max priority fee. Because if you don't have these values, you will not be allowed to sign the transaction, because you need to have all the values in the transaction. So yeah, okay, that's great question. Yeah, we don't need that. That's just like a little thing that he was asking. Let's continue with Aura. So to recap again, I just import Web3 and the Aura plugin. We initialize the Web3 provider to interact with the MetaMask. That's why I type window.ethereum. Then we register the plugin. And then we created this prompt, create an image of an apple with a tree. Then we need to estimate the fees. That is already working properly because we already estimated the fees here. Then the other function that we need to call is web3.aura.calculate AI result. And then this will receive these parameters here. It's really easy to use because you just put the parentheses and then you can see everything here. From is the wallet that is sending the transaction. So we need to connect MetaMask, well, like in the front end to the user. So we need to ask the user, hey user, connect your wallet. So to connect wallet, we need to type web3.eth.request accounts. And this will return the accounts that the user connects. I'm going to show you that as well right now. Let me just create another use state to show you account. Set account, no account. And then I will create account connected. Okay, so I have 0 fees, account connected, no account. And then when when the user called this function, web3.eth.request accounts, MetaMask will pop up and we'll ask the user, hey user, connect as many accounts as you want, but I will just use one. And then we can set account. This will be an array of accounts, right? And then we can just access to accounts. in the slot 0. And that will be the address of the first address that the user connects. So let's see if that works. Just comment this line. So far, this will set the fees and also ask the user to connect an account, which is really important because normally when we have a dApp, we always need the user to set an account, right? So okay, I have no wallet connected. So if I click here, first estimated the fees, and then MetaMask pop up and ask me, hey, connect a wallet. So I will connect this vault. Next, confirm, and then account connected. I just connected that account. Someone has any question with this? This is a really important thing using web3.js to connect the accounts to the dApp. Clear? Yeah.
Since you have to connect an account, is it necessary for it to be a MetaMask wallet, or should we use a smart wallet?
We use a smart wallet. Good question. I don't think, like, if you have another one, let's say I forgot the Rainbow or these other ones, then it will pop up that one. But then a smart wallet, I don't think that one will work, because then that will have like a different methods. But yeah, I don't have the answer to that one. That's a good question. I don't really know. We'll just need to install that and then try the same thing. But I don't think it will work, because the smart accounts, they are basically smart contracts. Well, I don't know if a smart wallet is using a smart contract as a wallet, but then they interact in a different way. That we have a plugin for smart accounts, but I don't know if a smart account will be the same as a smart wallet. That's a good question. That's a tricky one that I don't have the answer, to be honest. But we can look at that like later. But yeah, then I just connected to MetaMask. Another question? Yeah.
I don't understand where you are estimating the fees. Is it charging request or what?
Okay, good question. I'm estimating the fees of Aura. Aura is kind of asking you to estimate the fees of interacting with this model. So this is the fees of interacting with the Stable Diffusion right now. If maybe someone else try, or maybe let's try another model. So if we change the estimate fees for Llama 2, and then we click in send prompt to Aura, now the fees change. So this is the fees to interact with that model of Aura, in Sepolia in this case, because I'm connected to Sepolia. That fine? Perfect. Okay, so that's the first step, estimating the fees in Aura. So estimate fees. Just put here Aura. Then connect the wallet, because we will need to send a transaction. And then the second one is send the prompt. They call it calculate AI result. So this calculate AI result, first we'll receive the from. So who is sending the transaction is accounts in the slot 0. That's the address that we just connected. Then when we put comma, then we have the model. So in this case, the model is Stable Diffusion. Then when we put comma, the prompt. So we already have our prompt, comma, estimated fee. So it's just the fee that we just calculated here, fees. That's why we calculate the fees, because that's a requirement to send this transaction. And that's it. We need to say from the model, the prompt, and the fees. This will return a transaction hash, a transaction receipt, sorry. We don't really need that receipt for anything, but I'm just going to maybe to show it in the front end. So transaction hash. So this will return the transaction receipt once the transaction is confirmed in the blockchain. So sec transaction hash, transaction receipt. Transaction receipt is a huge object with different parameters, but we just need the transaction hash from that receipt. Okay, and this is basically how we interact with this. We are sending the prompt, in this case this prompt, then we need to wait a few seconds, maybe 30 seconds, and then I'm going to fetch the result. So to fetch the result, we just need to use web3.aura. I forgot the name of that one. That's in the docs here. Get AI result. Get AI result. And then here we only need to send the model, which is stable diffusion, and the prompt. So I just will put the prompt here as well. And then this will return the result. And then we are going to show it in the front end. Result, set result. Okay, and let me just show the transaction hash here as well. Transaction hash. And result. So the result will be IPFS hash where the image is located. So another question again, who don't know what is IPFS? So IPFS is Interplanetary File System, I think. And that's basically, let's say, in simple words, I would say like a free cloud where you can put URLs and how can I say that? This is a decentralized system of storing things. Yeah, storage. That's the definition. So what happens is that Aura will return an IPFS hash. Then we can go to ipfs.io/IPFS, and then we input here the hash that we just returned, and it will show our image. Because you cannot, it will not return an image literally, but you just need to render that image. So let's try this. So let's try this. I will just disconnect my account to show you everything again. So when I click here, this will first fetch the fees, then will ask me to connect my account. Then in the same function, we are calling the prompt. So it will pop up again to send the transaction, and then we will wait a few seconds, and then we will fetch the result. Let me see if I already set the result. Okay, then set result. Result. Perfect. If I click here, nothing. Okay, perfect. So send prompt to Aura. It first estimated the fees. Oh, I think I forgot to change to a stable diffusion. Yeah, stable diffusion. Because stable diffusion will return an image. So send prompt to Aura. First calculated the fees. I'm going to connect to this Vault wallet address. Next, confirm. Then we are connected. Then it will pop up again because it's calling this function, the calculate AI result from this account. Okay, it's having an issue. When it's showing these things, it's because there is an error and it will not work. So let's see what is the issue. Good question. What can be the issue here? Create image and open with a tree. We can try to call another model, because maybe the issue is not the code, maybe the issue can be Aura, but I don't think there is an issue. Count.address, model stable diffusion, prompt estimated fee. Or maybe the issue can be, no, estimated fee. I don't really find what can be the issue. So let's just try again, or let's just change the prompt, or let's just change the model. Sequoia ETH, and why this is not working. So yeah, if we run that, it's supposed to work, but it's not working. Oh, okay, maybe if I change this. And yeah, and it's not working. But that's how it's supposed to work, right? If maybe let's change the model to see maybe the issue is with the model. But I don't think so. That's weird. Let's try OpenLM. That's a really good question. Why it will not work? And I install it here. Aura. Yeah. I've done this like 10 times and 10 times work, but today it's not working. And then let's just try again with that one. Oh, okay. Now it's working. So maybe there is an issue with the stable diffusion right now. Interesting, yeah. So then if I click confirm, I'm sending a prompt that is create an image of an apple with a tree, but it's not creating an image. We'll return a prompt, so I don't really know which prompt will return. But yeah, that's weird. Maybe there might be an issue right now with the stable diffusion contract in Sepolia. Okay, transaction hash, that means that it just worked right now. It's just sent the transaction. If I try to fetch the result, there is no result yet because it's processing everything. We can come with the transaction hash to Sepolia ETHScan. We put the transaction hash. And basically it just interacted with Sepolia. And it was an expensive transaction. Yeah, if you need some ETH, you can let me know on Sepolia ETH. I can help you. And then if we try to fetch again, create an image of an apple with a tree, a sky and a star in the center, draw a simple shape such a triangle. Oh, okay, it's kind of giving you a tutorial to create an image of an apple with a tree. So yeah, but then if we call the stable diffusion, it will give us actually the image. I wanted to show you the image, but yeah, it didn't work. I don't know why. Let's try it again. Yeah, it's just not working. Another thing, let's see which model. Oh, I closed in the browser. I wanted just to try a different network, but I don't know if I have testnet tokens. Let me see which network they have. So they have Sepolia, Optimism, Sepolia. Okay, I think I have Optimism. Let's see. Someone has Optimism or Arbitrum Sepolia tokens that can send me? No? We are poor in testnet tokens. Something nice that you can use chain list. For example, I don't have Optimism here in my wallet. So if I want to add Optimism Sepolia here, I can just type Optimism.
What do you need?
Optimism Sepolia tokens. Or Arbitrum Sepolia tokens. Because I just wanted to try a different network. So if I click in Optimism, and then I click in include testnets, I'm going to do a bridge, and that will work as well. Then we can see Optimism Gorley testnet. I don't know if that will be. Maybe let's try Arbitrum. Oh, you have? Arbitrum? Oh, Arbitrum Sepolia? Okay, perfect. What's your Telegram? Let me. Ooh, that would be hard. Maybe you can. Oh, see? Okay, yeah, mine is Santiago Devrel. And then I will send you my address. Let's try again. Maybe now it works. Oh yeah, it's not working. Did you text me already? Yeah, maybe Arbitrum, please. Yeah, as you know, yeah, it already worked the Aura with OpenLM, but I still want to show you the stable diffusion. So we can come here, Arbitrum Sepolia. So I don't have Arbitrum Sepolia in my MetaMask. I come to chainlist.org, include testnets. You need to mark this. Then you can say connect wallet, and then it will add Arbitrum testnet, Arbitrum Sepolia to my MetaMask. That's why I love chainlist. and now I will have Arbitrum Sepolia here with 0.1 ETH that Oxodus just sent to me. Thanks so much, Oxodus, for the donation. Now let's try to call this in Arbitrum Sepolia. So the first thing that we need to do is to put Arbitrum Sepolia in the Aura plugin, and that's it. That's the only thing that we need to change. Then I will come here, I will make sure that I'm in Arbitrum Sepolia. And then let's see what happened. Okay, looks like it will work. I confirm. Interesting, let me, I don't have enough ETH. Oh, that was maybe a past transaction, I guess. I will text the Aura guys to tell them that there is an issue. Oh, I think the transaction didn't go through. Maybe an issue that can happen is that the transaction maybe is too expensive. That's something. Oof. This took over my ETH or what? I don't know. They stole my Sepolia. Let's see. Oh, maybe it's just delay. I don't know. Yeah, sometimes when the internet is slow, that can happen. That MetaMask pop up later. Let's try to confirm. Maybe that will work. Then let's see. Oh, that's. I don't know what happened with that. Yeah, so there is some issues with the contracts, I guess, because it's not returning the. Oh, okay. No, I know there is an issue that I have with MetaMask. This is just connecting the network, but yeah, I already showed you how that works with Sepolia, which was easier. I just reported to the guys that Stable Diffusion is not working, so let's just skip Aura. Now you know how that works. If you are getting issues, let me know and I can help you as well. Now, the most important part is to deploy the dApp on Flick. Because if we don't deploy the dApp on Flick, you will not be eligible for the bounty. So that's really important. You need to deploy the dApp on Flick. So we created this dApp, right? And then I want to deploy this on Flick. What I need to do is to go to flick.xys. I will create an account. I already have an account there. They also have a CLI, but for me it's just easier to come here. They locked me out. I don't know why. Let me try again. Okay, then I will need to create an account, I guess. Jesus Christ. A big. What is a big? Is this eagle here? Okay. Okay. Now we go to my email. That's important because the dApp needs to be on Flick. 6 to 9. Okay, then I'm here in my account. Then you will need to come to deploy your site. As you can see, I already have some sites here. Just click in Add New, deploy my site, and then you just connect your GitHub account to Flick. First, I need to push all the changes that I did. It's this one, yeah. Yeah, so I will just put everything. Okay, so I just push everything into the GitHub repo. I click here on GitHub. Then I need to select the repo. I already have some repos that I have here, but I will just adjust the permissions to give the permission of this new repo that I have. And then I need to select the repo from here, which is ETHSafari. Yeah, dApp ETHSafari. Save. So we are giving the permissions to Flick to read this repo. And then the dApp ETHSafari is here. I think that was the name of the repo. Let me just double check. Oh yeah, dApp ETHSafari. Deploy. If I come to dApp ETHSafari, oh yeah, that's the main folder. Then yeah, branch is the main. Publish directory is, oh, that's Vite. Okay, that already automatically kind of reads that it's a Vite framework. Otherwise, you can also check React. They don't have, oh yeah, they also have, okay, they updated Next.js here as well. And yeah, these are like the frameworks that they have. Deploy site. I always try this with React and it works. It's the first time that I will try with Vite or Vite. I don't know how to pronounce that one. Hopefully it will work too. And that's basically what you need to do. Connect your GitHub account to Flick, put your repo, and that's it. That will take 1 minute. And then that will give us, let me just come here to my sites. That will give us, for example, let's say this one that I was doing in Ghana. That will give us a link to our dApp. So in this case, that's the link, harsh ability puni.onFlick. And then I can come here, and then you can see my dApp here. So that's basically you will have a dApp for your portfolio at the end of this hackathon if you participate in these plugins. You can also edit the name of this hash. I don't know where. You will also have an IPFS hash. Oh yeah, maybe custom ENS. So I can put Santiago devrel.eth, and then by going to by here, custom domain. Santiago at ETHSafari. Oh, it's an invalid domain. Okay, I don't know. Let's never mind the custom domain. That doesn't matter. Let's see if our custom our dApp already deploys, or if we are getting an error. Where is it? It was deploying. Oh, it's deploying here. Okay, so it's here, still deploying. Yeah. But then we are going to get the URL here, or also the IPFS hash. That is basically a URL as well, but then you will just need to go ipfs.io.ipfs/, and then we can put the hash there. Let's just wait until this, okay, ready. And then I come here, and it's here. Our dApp is here. And then you can just send this link to anyone, and then you will be able to access to that dApp, and then view on IPFS. This is the hash. Okay, you can access to IPFS in this way as well. The hash.ipfs.theweb.link, and then let's try this way. ipfs.io/ipfs/ and then the hash. And the dApp is here as well. So what happened with the IPFS is that that's immutable. That's already in this hash. You can visit this hash in 1 year, and that will be there as well. So that's a nice thing to use IPFS. And yeah, that's how you deploy in Flick. Do you have any question with the Flick deployment? I don't work for Flick, so in case that something really advanced happen, I can connect it with the DevRels or Flick. But yeah, tell me. Good question. So then, if you do that, I don't think so. But then for your case, never mind about Flick. That's fine. You can do whatever you know and whatever you have. At least deploy that somewhere that we are able to use the app, and that will be fine. If you have like a server side, Flick doesn't set a server side. Yeah. Yeah, I will. Yeah, I will tell them that. I mean, in case that your dApp is a winner, yeah, don't worry in your case about the Flick, about the Flick parts. I will talk to them. That will be fine. Yeah, because the deployment of Flick is a requirement if you don't have a server, right? If you only have like one client, then you will need to do it. Yeah. You? Oh, you finished? Another question? Are you done with the question? Yeah. Okay. Perfect. Yeah. Oh, to ask the same. Yeah, so then in that specific case, yeah, then you can forget about Flick if you have a server side as well. Yeah, any other question with Flick? Okay, perfect. Because normally all the Web3 apps are just like that. A front end connected to a smart contract, and then you just deploy this front end in IPFS, and that's a dApp. Like Uniswap is already also in IPFS. Let's see if Uniswap IPFS link. And then you can come to Uniswap, and then they will have, maybe it's this one, Uniswap interface / IPFS, I guess, so that will be somewhere here. But all the dApps, if they are decentralized, they will have a IPFS hash, because this IPFS is immutable. So yeah, that's the deployment on Flick. This is the same things that I just showed you, but I have it in the presentation. The criteria. Really important. This is not a requirement. It will be really nice to have a clear README and how the plugin is being used. Because sometimes when we interact with the dApp, we have no idea how you are using the plugin. I mean, we'll need to read the code, but then it would be nice if you put it in text, how you are using the plugin. Then the second one, the plugin must be used in your dApp. Yes, you can imagine that there are some people that apply for the web3.js bounty without having a plugin in their dApp. So that's important to have. That's something that I really like that you attended the workshop, because then you are aware of all of these things. Then another thing, the dApp must be deployed on Flick, except if you have a server. Another thing, you can use multiple plugins in your dApp, but you will be eligible only for one bounty. So if you use, let's say, CKasync Paymasters and namespace, you will only win one to give the opportunities to other ones. And then the dApp must work. This is something really important that I saw in Nigeria and Ghana. We prefer something simple that works than trying to create the next Uniswap. Yeah. For us, literally, it doesn't matter if you have 100 smart contracts and no front end. Then that doesn't work. We don't want huge codes that doesn't show in a dApp. So focus more in something simple that works, instead of having a huge backend that do whatever you want. That's not the most important. Of course, if that's working with the amazing backend, maybe you will win, because I think that the logic is a lot, and then you will have the best use case. But yeah, focus on simplicity, something that works instead of something really complex. And once that's working, maybe you can try to add the complexity. And yeah, and then the code just must be public on GitHub. Any questions with the criteria? Perfect. This is how we are going to qualify to score the bounties. First, we are going to give points, and the one with the most, like with the highest points, will win. The innovation and creativity, 0 to 40. So how you are using the plugin. For example, for namespace, if you are only fetching addresses, that's one usage, right? But then if someone else is actually registering addresses, querying the addresses and whatever, then that person will have more points here, right? And this is the most important one, how you're using the plugin. The other one, 0 to 20 of the documentation. In this case, just like a simple README explaining how you're using the plugin. You doesn't even need to have codes. Just say, I'm using this plugin like this, like this, like this. Even if you add some feedback, I found that the plugin was really bad on this, or the documentation, there was no documentation for this, that will give you more points in the documentation. Then 0 to 20, the user experience. If I go to your dApp and I don't know how that works or where to click, or if I connected to Sepolia, but your dApp is on base, then that will be also a bad user experience, because no, you are not telling me in your dApp, please connect to Sepolia. So those little details will give a better user experience. Front-end design, we don't need something beautiful. That's why we just give something like the 10 points, but if it's beautiful, it will be nice. 0 to 5, if you make a video of the usage of your dApp, and 0 to 5 points if you make a tweet tagging web3.js and chainsafe th with whatever, like I just make my dApp, blah blah, at chainsafe at web3.js, and the link maybe to the dApp will be nice. or a photo of yourself or whatever. Any questions with this scoring system? Perfect. And then, yeah, the bounties, you already know the bounties. CK-Sync Paymasters, 2K, the first one. CK-Sync Paymasters, 1K, the second one. Namespace plugin, $700. Swisstronic plugin, $700. Aura AI, $700. CK-Sync in general, we call it in general, that means that any type of usage that is not the paymaster, that will be $500, and then runner-up, $400. Then here in this bounty ideas, you can visit this spreadsheet, and then there are some ideas of dApps that you can build. For example, AI, the Aura AI referee on-chain gaming, or decentralized grant distribution engine, or namespace. You can create a dApp that can do the custom domain registration dApp. Like I go to your dApp and then I can put input Santiago DevRel, and then I want to buy this domain. So you can also have this type of dApps. It doesn't have to be like this, but this is just giving you some inspiration. And you can visit that in that spreadsheet. And yeah, let's keep in touch. You can follow us, ChainSafetyH, web3_JS, Santiago DevRel, and you can follow Red One as well. I don't remember right now. I think it's Redodo M. You can follow Red One as well. And then web3js.org/plugins. And that's basically the workshop for today. 2 hours. Wow, that was long. Any questions before we go downstairs? Sorry? Slides. I will publish on my Twitter, yeah. Anyway, I have been publishing this.